Here in assignment 15, question number 2, I didn't correctly carry out the power average relationship. As you can see, I take half of the real part of the complex conjugate v times I. And when you take the complex conjugate, the sign for j becomes opposite. So I included this here, and then I carried it out here. And when you take the real part of this, you only get 0 because there's only an imaginary part, and 1/2 times 0 is 0, so the power average is 0. In question number 3, I forgot to mention that the 3 decimal point is the cutoff frequency, meaning that the voltage out over voltage in ratio is 1 over radical 2, and this is a very important fact. In question number 4, I didn't, explain a lot, so I would like to add, besides that Q is very important for hearing just one radio station and determines the sharpness of the resonance curve, the Q factor determines the bandwidth of the frequencies that any given resonant frequency selected on a radio will have. So a high Q will have a more selective range of frequencies, but will also be more difficult to tune into. And there are other things to consider too, and this all depends on the components: resistor, capacitor, inductor. In assignment number 19, question number 2, I replaced the graphs. These are the new graphs where you'll see there's an alternating voltage, but because of the diodes, the voltage is cut off at 0.6, and that is why it looks like this. And because of the diodes, because the diodes cause the current to flow in one direction, which is why there's no alternating current. You only get current in the positive direction here over time. In question number 3, there were a lot of bad math errors, so I revised this where I set the expression equal to 0.1, and I carried it out to find the capacitance to be 0.02 microfarads. In part B, the peak voltage is 10.8 because at any given point the current will travel one of two paths, which includes two diodes, and the voltage drop across a diode is 0.6, so 0.6 times 2 is 1.2 volts, and that leaves the peak voltage to be only 10.8 volts. For part C, we'd expect a ripple because of the charge and discharge of the capacitor, which I forgot to add in my original answer. In question number 5 for assignment 10, I didn't have a very good proof here, so I gave it another shot for a simpler expression, just A or B, and the first rule of the De Morgan's theorem states that the complement of A or B replaces the OR gate with an AND gate, and this is very convenient because we would have to take the complement again to make this a NAND function, and the second complement of any A or B would equal itself. So that's how you turn that into NAND logic. In addition, I'm going to skim back to, where is she?